Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list topic, and we were solving second pattern, that is fast and slow pointer. And today from this pattern we'll solve the next question, which is how to detect linked list cycle. So let's read the problem statement. We will be given a linked list and there will be a cycle or not. We have to return true if there is a cycle and false if there is not. So let's read the constraint. The constraint says a number of nodes will be from 0 to 10 power 4. Okay. So basically we have to solve this in O of n. Anyhow, in linked list we already discussed multiple times ki very rarely we'll be solving questions using O of n square time complexity, but mostly we'll be having in just O of n. And regarding the different types or different patterns of linked list, we have already discussed in the very first video of this playlist. I'll add the link somewhere here, you can definitely check out. Or in case if you find difficulty in calculating time and space complexity, that too I have covered in full video. You can definitely check out the video, I'll add the link somewhere here. So let's start. So this is a linked list we have. We'll be given a head pointer and we have to return true or false depending upon the case if we have cycle there. Okay, so suppose we don't know about fast and slow pointer, because in linked list we already know there are some basic operations that we already covered, then a pattern called fast and slow pointer that we are covering now, and then there will be a pattern where you have to use the reverse logic, but in this case we will not use any reverse logic, and then there will be a pattern where you have to do merge or sort type of algorithm in the linked list. So in this question we have to use fast and slow pattern. But before doing the optimized approach through fast and slow pointer, let's try to understand how we can do this using the brute force approach. Okay, so we have to check if there is a cycle or not. So don't you think to check cycle we can say ki hey, we have marked, like we have visited 1, okay, we have visited 2, okay, now 3, now 4, now 5, now 6, and after 6 we again came back to 2. So don't you think if we will store all these visited nodes somewhere, okay, and next time if we are visiting again, then we can check from our storage ki hey, did we visited this node earlier? If yes, it means there is a cycle, means return true or else return false. Now the question is ki do we need to store the node or do we need to store the value? Obviously node. Why? Because suppose if we have 1, 2, 2 and null. As you can see there are no cycle present. But if you will save one, like if you will save the value in your storage, let's say HashSet. So if you will store 1, okay, if you will store 2, okay. Now next time when you will reach this 2 node, which is obviously unique, but if you store the values, your hash set will say this is already present. So yes, there is a cycle, but this is not. So hence, instead of storing values of linked list or values of nodes in your hash set, it's always preferred to store node, because node store value also as well as next node address also. So what we'll do, we'll make a alias, let's say current, and as you know we do not prefer to move head pointer, we make alias, let's say current, and we'll move this current ahead. So first we'll check, is our current already visited or present in the set? No, it is not. So okay, we'll move ahead, and while moving we will save in our hash set. So first we'll make our hash set of type node or list node, whatever we have made. Set is equal to new hash set and so on. Okay, now we'll make a current pointer of type node and we'll start from the head location. Now we have to continuously repeat the same process, so we'll add in some while loop condition and we'll check ki if our set contains that current, means if that node is present, then we can simply return true saying yes, cycle present, or else we'll keep on moving our current ahead by current is equal to current dot next. But remember, before doing this we have to set, like we have to save our current node in the set, so that for next time we could have something to test, right? So hence here in the set we will add our current node, and that's it. After coming outside we will return false if there was, like if the node was not present in the current. But what should we add in this while loop? See, in this case, current, and when this current node hits the 2 again, we can simply return back. But what if there is no cycle? So definitely we have not added any return statement apart from this. So if there is no cycle, it means we will get stuck in an infinite loop. So there should be some condition to come out, correct? It means if there is no cycle, for sure that linked list is a straight linked list. Means there will be a null pointer. 1, 2, 3, 4. Null. Correct? So in this case, if this condition will never become true, for sure there is no cycle in the linked list, and in that case current will move to null. Correct? And that should be the stopping condition for this while loop. So what should we write? Current, while current not is equal to null, keep on doing this. So while current not is equal to null, this condition will check if there is anything we have encountered double time, it means cycle is there and we will return true. Otherwise we'll keep on adding and keep on moving our current ahead, and coming outside, if there was no true returned, it means there is no cycle, so we'll return false then and there. But what is the time complexity in this case? See, we have initialized our current and we have moved to every condition, definitely O of n time complexity. But as we have initialized this space hash set, so definitely this is going to take further O of n space complexity. So in total O of n time complexity and O of n space complexity. This is optimized because in linked list you will rarely see any quadratic or n square or n cube solution. Mostly you will see linear solution only. But the optimized approach will be if you can save extra space or extra time complexity. So in this case we are using extra hash set. So is it possible to do without using any extra hash set? Yes, we can do. And that optimized way will be solved by using fast and slow pointer pattern. But what is that fast and slow pointer when we say? See, in the previous video we have already saw how do we calculate the middle of the linked list using the fast and slow pointer. Why? Because with the concept ki slow will always move with one speed and fast will always move with double the slow speed. So definitely at any point of time slow will always covered the half of the distance, you can say, compared to the fast pointer. Yes. So in this case, how it will help us to calculate or to check if there is any cycle? See, if we will start both pointers from the same location, correct, and if there is any cycle, okay, and one person is moving with double speed or more speed than the previous one, don't you think in the same cycle they are going to collide again? If there is a, see, if there is straight track, correct, and if you are moving with double speed than this person, slow, definitely you are going to finish the race first. But if the track is circular, you have started with the same point, definitely slow will be somewhere here, you will be somewhere here, fast, then again slow will be somewhere here, correct, and fast will be somewhere here, correct. Now next time slow will be somewhere here and fast will again come here now. So you are going to collide with the slow if the two person are moving with the different speeds, correct. So if there is any cycle, for sure the slow and fast who are moving ahead with different speeds will collide for sure. And if they collide, we can say, yes, we have found that there is a cycle. And if they do not collide, means in a straight track, fast pointer will become null, correct, or its next will become null before the slow. So if your fast or fast dot next becomes null, you can say ki yes, there is no cycle present. But if your slow and fast become equal in the same while loop, you can say there is a cycle present. So let's do the dry run for it. We'll start our slow and fast pointer, and as we know fast is moving with double speed, so fast will take 2 jump and it will come at 3, and slow will take 1 jump and it will come at 2. In the next iteration again fast will take 2 jump, it will come at 5, and slow will take 1 jump, it will come at 3. In the next iteration again fast will take 2 jump, it will come at 2, and slow will take 1 jump, so it will come at 4. Now again in the next iteration fast will take 2 jump, it will come at 4, and slow will take 1 jump, so it will come at 5. Now again in the next iteration fast will take 2 jump, it will come at 6, and slow will take 1 jump, so it will come at 6. And now at this position fast and slow met. So So we can say yes, there is a cycle, because if there is a cycle and if two persons are moving with different speed, definitely they are going to collide again at some point of time or after some interval. So this 6 is the point where they met. So we can say yes, return true. So let's write the code for this. So first we'll make of type list node, we'll make slow pointer pointing to head, and similarly list node fast pointer pointing to head. Correct? Now in the previous video we already saw ki what will be the while condition, because fast is moving ahead, so definitely fast will become null, or like for even and odd length. I already told you in the previous video. So for both even and odd we have to write two cases, for even and for odd, ki while fast not is equal to null and fast dot next not is equal to null. It like this is a base case ki if it is a straight line and there is no cycle, definitely we'll come out of this loop and we will return false ki hey, there is no cycle. But what if there is cycle? So if there is cycle, definitely we have to write slow is equal to slow dot next, move slow for one time, and fast is equal to fast dot next, means move your fast pointer two times. And if in between slow becomes equal to fast, then we have to return true then and there. Very simple. So now we can run the code. As you can see here also the time complexity, did I miss something? Okay. So as you can see the time complexity will be O of n. Why? Because fast is moving ahead. Yes, correct. But the space complexity will be constant. Why? Because here we have not used any extra space. We just do two different pointers, that will be constant space. So this is the optimized code using fast and slow pointer. Okay. And whenever it is about middle point or meeting point, which can be solved using different speeds, we follow fast and slow pointer. Okay. So this was the code in Java. Here is the code in C++ if you are from C++ background, and here is the code in Python if you are from Python background with a similar approach. So I hope you understood. If yes, then definitely you can go in the sheet and mark the second question also as done. So in the next video, we will see how to detect the starting point of the cycle, and we will also see the proof of that. So stay tuned, and if you have any doubt, do let me know in the comment section, and please subscribe the channel if not yet subscribed. And that's it. Let's meet in another video with some more interesting questions, patterns and topics. Till then, keep learning, take care of yourself and your family.